Hello, in today's video, we are going to walk through how to implement a stack. Pre-quiz, how would you write your own class that behaved like a stack? So could you write your own class that had a push, pop, top, and is empty method, basically, all the methods of the stack. And remember the basic operations here, push, pop, top is empty, this is what they do. Now, here's our main insight here is we're going to use an array. Our class is going to maintain an array that is going to be partially filled. And that's going to basically be our stack. Now, around this array, we're going to have all our operations to work with this. And we're also going to keep track of this other variable called used, which will represent how many slots in our array that we have used. So for example, if we were going to push the letter H onto our stack, this is what our array will look like. Index 0 will have an H, and the number of used elements goes up by 1. If we push another element, a U, then U is at index 1, and the number of used elements is 2. And so on. R, we push an R, push an A, I think push another R, push another A, push an H, all right. So we push the word hurrah one by one into our stack. We have 6 used elements. What about top? Well, as we'll see, the array combined with this used variable gives you everything you need to get the top element. So here, suppose that this is our array, you get the value stored at used minus 1, right? So used is 6 elements. So 6 minus 1 represents the very last element that was put into our stack, which will give us the H. What about pop? Well, all we need to do is decrement used. So used goes from 6 to 5. We don't actually need to do anything to our array. As we'll see, and you can even kind of connect this to what you saw on the previous slide. When you call top now, remember top is array at used minus 1. Okay, used is now 5, right? So used is 5. So then top would be given by array at used minus 1. So used is 5, so we would now get A. So it's as if the H disappeared. Okay, so that's it. This is the main mechanism behind how we're going to implement our stack. So let's jump into some code. Okay, so starting from scratch here, let's create a stack class. All right, and it's going to have some private and public variables. And we're also going to define our max, the size of our stack. And I'm going to introduce a new technique here, which is to use this preprocessor directive #define, which is another way of defining a variable. So here, we're setting this max variable to be 1,000. And what that allows us to do now is we can use it when we initialize our array. So let's call it vals, and it'll start out with 1,000 elements. Note that we're using int. To simplify our implementation of the stack, we are going to assume that the stack only stores integers. Okay, if you wanted to make this more extensible, scalable to a variety of data types, you would need to use something called the template class, which is out of scope for right now. Okay, so we've declared our array, and we're going to declare our used variable. And I'm going to put underscores in front of these because, as a convention, I like to have my private variables be prefixed with that underscore. Now, for the public, we're going to have our methods. We have push. We have pop, which returns an int. We have top, which also returns an int. Oops. And we have isEmpty. Okay, great. Now, let's also split this up into its own file. Remember that technique when, in order to make a class reusable, we'll put it into separate files. So I'm going to make two new files, stack.h and then stack.cpp. So in the header file, I'm going to put everything that I just typed. All right, there you go. Now, hold on one second. Okay, now we have our header file. We also need to use our special preprocessor directives here to make sure that we are not including the header file more than once. So if you remember how this is done, we can define our variable. Sorry, if not defined, then define, and then we'll have our end if down here. Great. Next. So I think we can delete this now. Okay, and then up here we'll include our stack.h. Remember the quotes there. Next is our stack.cpp file. So we're also going to include our stack.h. Let's go ahead and include everything else we need as well. Stream using namespace std. And now we're going to implement our methods. So I'm just going to copy these over here. Let me just do that. I'm going to put that stack prefix in front of all of these. And then let's turn these into functions like so. There you go. Oh, one other thing, we need a constructor as well. So let's make a stack constructor in our header file. And then going back here, it's going to be stack, so on. All right, so what's our constructor going to do? This is just going to set used to be 0. Right, because the stack starts out without any elements, so used is 0. Next, push. We are going to be given an integer, and so we're going to set our vals array to contain that integer. Now, what index are we going to store this new integer in? Well, it'll just be at used. And then we're going to increment used ++. Okay. Now, what else do we want to do here? Let's implement top, because then we can test our code right away. Top is going to be, we're going to return something, and we'll return vals at, if you remember what it was used -1. Okay, we now have enough to test our code. So I will just, I think the compiler will throw an error if I don't do something with, so I'll just comment these out. And let's see if it runs. All right, no, it did not run. Okay, so we've got line 4 of stack.h. Don't think I need a semicolon here. Okay, now it ran. No, it didn't. Max is redefined. Interesting. Oh, that's because probably in main.cpp, I still have it. Yep. So you can only have that defined once in your whole program. Got it. Let's try it again. Stray in the program, line 30. Yep, there it is. All right, great. Do you see how many problems that I fixed just because I tested my code early? All right, next thing, we're gonna, well, I don't know if my code actually works. Even though it ran, I don't know if the logic is doing what I think it's doing. So how can we test this out? I can start by declaring the stack, an instance of the stack, and then I'll call the push method, and then I'll call top to see if it actually works. That'll be my test. We've got stack, my stack, and we'll do my stack dot push 3. Let's call it again. Oops. My stack dot push 5, and then let's call my stack dot top, and let's see what we get. We should get 5. Nope, we get 0. Interesting. I wonder why. Let's see. Oh, yeah. This doesn't actually do anything. Okay, equals x. There we go. Let's try it again. Now we should get 5. All right, now I'm convinced the code works. Let's move on to the next thing. We're going to implement pop. So pop is relatively simple. Just decrement used. That's it. And then is empty. Well, let's test that, right? In the spirit of testing as we go, I'm going to write something here. Let's do my stack dot pop. And then to test it, I'm going to call top again. And now I should get 5 and then 3. There you go. So I'm convinced pop works as expected. The next thing is empty. We're going to basically return whether or not used is 0. So we could do something like this. If used is equal to 0, return true, else return false. Now, to simplify this, we can instead just write return used is equal to 0. Same thing. That's because this evaluates to true or false, right? So this is a little bit shorter. Now, let's test that one out. So we've got main. Let's start out. We'll print out is my stack dot is empty here. And then I'll even put a little message here, is empty. And then I'll copy this and then paste it down here, is empty. So we should see that here it's true and then here it's false. Okay, there you go. Is empty is true to start with, and then it's false at the end. All right, there you go. That is how you implement a stack.